In 1998, in AB 1998 number 79, which is also a calculator question, even though you really couldn't use a calculator in this particular case. The graphs of the derivatives of the functions f, g, and h are shown above. Which of the functions f, g, or h have a relative maximum on the open interval for x's greater than a, less than b? Well, I made a note here that f, g, and h will have a relative maximum when f prime, g prime, h prime, respectively, change from positive to negative. What's important again in this particular problem is that the graphs that you are shown are not graphs of the functions. If you look carefully, they are graphs of the derivatives of the functions. And so we are looking for where those derivatives, respectively, change from positive to negative. We can see on the graph of f prime of x that there is only one change from positive to negative that occurs near b. The other ones near a, it goes from negative to 0 to negative, so that is not a relative max or a relative min. We would call that a stationary point, but it is neither a max or a min. The point near the origin is a point at which the derivative changes from negative to positive, and so that would be a minimum in the original graph. Only the point near b would be a relative maximum. Now in the second graph, the function only crosses the x-axis one time, and there it crosses from negative to positive. And so that value would be a minimum on the original g of x curve. In the third graph, h prime of x, the derivative never crosses the x-axis. It's always positive, and so there will be no mins, maxes, or stationary point. And so from this you can see that the graphs of the derivatives are shown above. Which functions have a relative maximum? You can see that f only has the relative maximum. And so the answer to that would be A. Again, what's complicated about this problem is that you're actually shown the derivative function, but you're asked about the original function. So you have to think in terms of a max in the original function occurs when the derivative changes from positive to negative. Okay, so that's it for this particular problem.